Hello student, today I will discuss the numerical step questions which are frequently come in your board examinations. Basically these questions are model paper questions. Okay, these questions are directly come in your final exams directly. So these are very important. Now we will discuss each questions one by one. Now see, first question is the boiling point of benzene. The boiling point of benzene is 353.23 Kelvin. Calculate the mass of non-volatile solute is to be added to 90 gram of benzene such that it boil at 354.11 Kelvin. The molar mass of solute is given 58 gram per mole and Kb is given 2.53. Simply this question belongs to the colligative properties, elevation in boiling point. As we know the formula of elevation in boiling point, delta TB is equal to Kb into M, where M is molarity. As we know this formula. Now delta TB is T final minus T initial. T final minus T initial. Final boiling temperature minus initial boiling temperature. Okay, is equal to Kb into M. M is molality. How can we write the molality? Like molality is equal to mole of solute and solute upon weight of solvent in kg. Weight of solvent in kg. Okay, now this is final temperature is, and further we write Kb is equal to weight of solute. Mole is equal to weight upon molecular weight. Weight of solute upon molecular weight of solute. Molecular weight of solute into, if weight is given in gram, as it is given in gram, then we multiply in upside by 1000. This is weight of solvent. If weight of solvent in gram, then multiply by 1000. Okay, convert into kg. Now we put the value. Now we will put the value of each delta Tf, Ti, Kb and weight. The value of delta Tf is final temperature is 354.11 minus T initial is 353.23 and is equal to sorry, this is Kb into. Okay, now and the value of Kb is, as it is given, value of Kb is 2.53 into mole of weight of solute. We have to find out the weight of solute, and molecular weight is 58 and weight of solvent in gram is 90 into 1000. Okay, now finally we got from here, as we know, if you minus 354.11 to 353.23, what we will got answer? This is 0.88. If you minus this, we got 0.88 is equal to 2.53 multiplied by weight. We have to calculate weight upon molecular weight is 58 into 90 and multiplied by 10 to the power 3, that is 1000. From here we calculate weight is equal to 0.88 multiplied by 58 multiplied by 90 upon 2.53 into 10 to the power 3. Okay, after calculating this, we will got weight is equal to 1.81 gram. 1.81 gram answer. Okay, by calculating this. Okay, now we see the next question. In next question, it is given that calculate the mass of non-volatile solute. Calculate the mass of non-volatile solute which should be dissolved in 114 gram of octane to reduce its vapor pressure to 80%. To reduce its vapor pressure to 80%. given molecular formula of octane is C8H18 and molecular mass of solute is 40. How can we calculate? As we know here, it is given in vapor pressure. In term of vapor pressure, how we calculate the molar mass or weight? By using relative lowering in vapor pressure formula. First colligative properties, that is delta P upon, as we know, delta P upon P naught is equal to x2, that is equal to n upon n plus n. This is mole of solute upon mole of solute plus mole of solvent. And for very dilute solution, n upon n, this is equal to delta P upon P naught is equal to n upon n for very dilute solution. For very dilute solution, dilute solution. But delta P upon Ps is equal to n upon capital N for any solution. For any solution, whether it is dilute or concentrated, does not matter. For any solution, this formula is valid. Any solution. Now we calculate. Now in term of percentage, the pressure is given in term of percentage. If percentage in term of percentage are given, then initial pressure, that is P naught is equal to 100%, and Ps given after adding non-volatile solute, its pressure reduced to 80%, that is Ps is equal to 80. Now by putting this in the formula, we calculate simply the mass of solute. Simply put the value and get the answer, that is delta P is equal to P naught minus Ps upon Ps is equal to n of solute. N of solute, that is weight of solute upon molecular weight of solute. Upon में mole of solvent, that is weight of solvent upon molecular weight of solvent. Okay. Now by putting this, putting the value of this, we get P naught is given 100 minus Ps is 80 upon Ps is 80 is equal to weight of solute. We have to find out. We have to find this W upon molecular weight of solute is given 40. Okay, 40, that is given molecular weight of solute upon weight of solvent already given 114 upon molecular weight of solvent. As we know, octane are given. Octane, molecular weight of octane is C8H14. Now one carbon atomic weight of carbon is 12, and how many carbon are there? 8. 12 into 8 plus atomic weight of hydrogen is 1, and how many hydrogen? 18. That is 12 into 8, that is 96 plus 18. 96 plus 18 is 114. The molecular weight is also 114. So weight of solute upon molecular weight of solute, that will be cancel out. Now answer will be 100 minus 80. 100 minus 80 is 20 upon 80 is equal to weight upon 40. Okay. Now after cancelling this 0, and this 2, this 4, answer will be this 1 by 4 is equal to W upon 40. Now W is equal to 40 upon 4. 40 upon 4, that is 10 gram. Okay, 10 gram answer. Okay, answer will be 10 gram. Hope you got the answer. Now see the next question. Next question, it is given the rate constant of reaction quadruple. Quadruple means 4 times. Quadruple when the temperature changes from 293 Kelvin to 313 Kelvin. Calculate the energy of activation, that is activation energy of the reaction, assuming that the it does not change with temperature. Okay, that is activation energy does not change with temperature. Now how can we find out the value of activation energy? By using the Arrhenius equation, derived form of Arrhenius equation. What is the derived form of Arrhenius equation? That is ln, simply we can write the log base 10 K2 upon K1, K2 upon K1 is equal to EA upon 2.303 R T2 minus T1 upon T1 T2. By simply putting the value of each component, we can get simply the answer. Okay. Now put the value log. The K2 become quadruple. Quadruple means 4 times of K, and initial K value of rate constant is K. Now EA we have to find out. We have to find out value of EA upon 2.303 R. Value of R is 2.303 R. Value of R is 8.314 in term of joule. Now T2 minus T1. T2 is 313 minus T1 is 293 upon T1 T2. That is 293 multiplied by 313. Okay. By simply solving this, we can get the answer. Now value of this become log 4. Value of log 4 is 0.6. 0.6 is equal to EA upon 2.303 into 8.314 multiplied by, that is 313 minus 293 is 20 upon 293 into 313. Simply from here we get EA is equal to activation energy is equal to 0.6 multiplied by 2.303 into 8.314 multiplied by 293 into 313 divided by 20. Okay. By multiplying this, we get the value, that is 10107,196.42 upon 20. 1946 1957 1057,196.42 upon 20. The value will be 52.85 kilojoule per mole. This will be the answer. 52.85 kilojoule per mole answer. Okay. Hope you got that. Now, if you see next question, in next question it is given, calculate the value of EMF of cell. That is E cell. We have to find out value of E cell. For a given reaction, reaction is given Mg solid plus Cu plus 2 aqua, and the concentration of Cu plus 2 aqua is 0.0001 molar. Give Mg plus 2 aqua, and concentration is 0.001, and Cu plus Cu solid. And given in the question given, E naught of reduction potential of magnesium is, magnesium reduction potential is minus 2.37, and reduction potential of copper is 0.34, and we have to find out the value of cell. How can we find out the value of EMF of cell? By simply using the Nernst equation, and we know the Nernst equation is, how can we write the answer according to Nernst equation? According to Nernst equation, as we know, E cell is equal to E naught cell minus 0.0591 upon n log product concentration of product upon concentration of reactant. Okay. E cell is equal to E naught cell minus 0.0591 product concentration of product upon concentration of reactant. Now if we find out the value of E naught and concentration of product given, concentration of reactant given, and value of n, number of electron gain or loss in the reaction is value of n. What will be the value of n? This magnesium loss how many electron? 2 electron. Value of n will be 2, either gain or loss of electron. This copper gain how many electron? 2 electron. Value of n will be 2. Value of n will be 2. And how can we find the value of E naught? E naught simply not given. How can we find value of E naught? E naught is equal to, as we know, from here we can calculate E naught is equal to E naught cell. E naught cell is equal to E cathode minus E anode. How can we identify that which one is cathode and which one is anode? Maximum the value of E naught, maximum the reduction potential, that will be the cathode, and minimum reduction potential will be anode. So this will act as, the copper will act as cathode and magnesium will act as anode. Okay. Now simply by simply by subtracting the cathode and anode potential, we get value of E naught cell. What will be the value of E naught cell? That is 0.34 minus, and value of magnesium is minus 2.37. Okay, now from here we got the value of 0.34 plus 2.37. Answer will be 2.71 volt. Value of E naught will be 2.71 volt. Now by putting the value here, we got E cell is equal to E naught cell. We know the value of E naught cell is 2.71 minus 0.0591 upon 2 log product concentration. As you know, concentration of product is 0.001 upon reactant concentration is 0.0001. From here we get value of E cell is equal to 2.71 minus the value of this will be 0.0295, and this become log 10. This become log 10. By equating this become log 10. And value of log 10 we know 1. The answer will be 2.71 minus 0.02951. 295. Okay. Now value of E cell will be 2.68 volt. The value of E cell will be 2.68. This is our answer. Okay. Hope you got the answer. Now next question we see. The question is given from the chapter chemical kinetics. That is C14 content of an ancient piece of wood was found to have 3/10th of living tree. Calculate the age of that piece of wood. Given that half-life of C14 is 5730 years and value of log 3 is 0.4771 and value of log 7 is 0.8540. Now how can we calculate? From here, as we know, if we want to calculate the value of the age of the tree, then we have to know the value of K. First of all, by applying the first equation of first order, because all the radioactive compound, radioactive decay follow the first order kinetics. That's why we apply the equation for first order kinetics. That is 2.303 log A naught upon 80, A naught upon 80 is equal to KT. Okay. From here we know initial concentration is the amount of piece will be A naught, and after some time its value will be 3/10 A naught. From here we have to find the value of T. Now if we find the value of T, we should have to know the value of K first of all. How can we find the value of before solving this equation? We have to find the value of K. Now how can we find the value of K? For finding the value of K, it's given half-life. The hint are given, value of half-life is given. From here, from this half-life, we can calculate simply the value of K. As we know, for T half, for first order, T half is equal to 0.693 upon K, 0.693 upon K, and from here K is equal to 0.693 upon T half. 0.693 upon T half. The value will be 0.693 upon value of T half is 5730. 5730. Okay. This is the value of K. By simply putting the value of K here, we got the answer. Answer will be 2.303 log A naught upon 3/10 A naught is equal to value of K is 0.693 upon 5730. Sorry, 5730 into T. From here, simply we can calculate the value of T. Here A naught cancel and it become 2.303 and this become log 10 upon 3, and if we multiply here, this become 5730 upon 0.693 is equal to T. Now if you find the value here, that is 2.303, and this is log 10. Log A upon B is log A minus log B. Log 10 minus log 3 into 5730 upon में 0.693 is equal to T. From here we can calculate T is equal to, if we multiply this 2.303 and this become 1 minus log 3. 1 minus log 3. Log 10 is 1 and log 3, value of log 3 is 0.47 it is given. The value become 2.303 into, after subtracting this, we got 0.523 into 0.523 into value will be 5730 upon 0.693. This become this value become after calculating this value become after calculating by putting this value on calculator, you will got simply the answer will become 9957 years. Okay, that is answer will be 9957 years. This will be the age of tree. Okay, hope you got the answer. Now if you see next question, in next question it is given the limiting molar conductivity of acetic acid, that is CH3COH, is 390 Simon centimeter square mole inverse. Using the graph and given information, calculate the limiting molar conductivity of salts, that is potassium acetate CH3COK. Now from Colos law, as we know, the molar conductivity of weak acid or base or weak electrolyte, that is CH3COH is equal to molar conductivity of salt, that is CH3COOK plus molar conductivity of a strong acid, that is HCl, minus molar conductivity of KCl. Okay, from here we get the value of lambda CH3COH, that is infinite dilation, 100 molar conductivity. Okay, now from this information, as we know, this is the and this value is given for HCl, lambda HCl. This is HCl value and this is KCl value. From here we have to find the value of lambda CH3COOK, that is molar conductivity of potassium acetate. From here we can write lambda, that is molar conductivity of CH3COOK, is equal to lambda naught CH3COOH, and if we put this side, what we will get, value of this become plus and this become minus, that is lambda naught KCl minus lambda naught HCl. Okay, this we will got by rearranging this equation. Now from here we can simply calculate the value of molar conductivity of potassium acetate by putting the value as it is. As we know, the value of lambda CH3COH is given 390 Simon centimeter square mole inverse, and value of KCl, from here it is given that this is 175, this is 125, then this become 150. Value of KCl will be 150. Okay, and minus that is minus lambda HCl, and value of lambda HCl is 425. Now come 114 Simon centimeter square per mole. Okay, this will be the value of lambda CH3COOK. Okay, now this will be the final answer from the graph. Okay, this is very simple question. Hope you got the answer by applying simply Colos law. Okay.